Hey class, today's lesson is on solving a quadratic equation in vertex form. So up to this point we have solved quadratic equations by graphing, factoring, and quadratic formula. Now once we're in vertex form, how do we solve it this way? Well, what we want to do is, again, as you already know, we're going to set the equation equal to 0, and now we're going to solve for x. So we're going to undo GEMDOS. We want to isolate the x. So we're going to start by undoing, adding, and subtracting first. So we're going to undo the subtraction with addition. Okay, that's done. Then we're going to undo any multiplying and dividing. We have times 2 in the front. So we're going to divide by 2 on both sides. Okay. Next thing we're going to do is take care of the exponent. So to undo squaring, let me change colors here. The inverse of squaring is to take the square root. They're inverses, so we're going to take the square root on both sides. And so those cancel. Now this is very important. When you are solving an equation and you're taking the square root, you need to put the answer in a positive and negative format. So the square root of 4 is going to be positive 2 and negative 2. Why? Because 2 times 2 gives me 4. That's 2 positive 2's that give me 4. But we can also take 2 negative 2's and also get 4. So when solving, remember, for quadratic equations, there's always going to be 2 solutions, sometimes real, sometimes complex. In this case, it's going to be real. So finally, we're now inside the grouping symbol, which is the x minus 1. And once you get inside the grouping symbol, we start all over again, undoing, adding, and subtracting. It's like entering the inside world. Adding 1 on both sides, we get x equals. Now, to get our 2 solutions, just like using the quadratic formula, we use one operation at a time. So start with the positive 2. So positive 2 plus 1, 3. That's going to be one answer. The other answer, using the other sign, negative 2 plus 1, negative 1. And there are your 2 rational solutions. Okay, let's look at another example. So the first thing we want to do here is we want to set the equation equal to 0. I'm going to move it over here on this side. And now we're going to use the same process that we just used. We're going to start by undoing, adding, and subtracting. Undoing, multiplying, and dividing. Undoing the exponent. Don't forget, even though we can't take the square root of negative 2, we still put the plus and the minus. Don't forget that. When you're solving an equation and you're square rooting something, you need the plus and the minus. I'm going to go ahead and simplify this. And that's going to be the square root of negative 1 times the square root of 2. And we know the square root of negative 1 is I. And then we put the square root of 2 down. Finish solving for x. And there are our 2 solutions. So if you want to write it out, make you feel better, we'll use the positive I radical 2 minus 4 and the negative I radical 2 minus 4. Now some of you might be asking, well, Mr. Kramer, I thought that the real part goes first and then the imaginary part. Yes, you're right. Thank you for asking. Negative 4 plus I radical 2, negative 4 minus I radical 2. Technically, it's the same thing, but usually we write the real number first and then the imaginary part for our complex solutions. Okay, let's look at one more example here. I already have it set up. We have it in vertex form, set equal to 0. Go ahead and solving it. All right, so here we are, undoing the square root. Undoing the square with the square root. Don't forget, when you take the square root of a number and you are solving, we put the, good, Megan, good, the plus and the minus. Finishing up, isolating the x, and there's your two answers. And of course, you can break it up into two answers if you like. Now here we have an irrational number, so the type of solution is irrational. Okay, because we have a radical in the answer. Whereas here, the type of solution here is complex, because we have a real and imaginary part. And then up here at example 1, we have rational solutions. Remember that rational numbers can be put into fraction form. So like 3 over 1, negative 1 over 1, those are rational numbers. The square root of 2 or square root of 5 cannot be put into fraction form, so that is irrational. All right, and there you go. If you're still struggling with going from standard form to vertex form, stay tuned, okay? And I'm going to do another example of how to do that. If you're good with changing from standard to vertex, then you can shut the video off at this point, okay? So going from standard form to vertex form, let's go ahead and write an equation in standard form. All right, and now we're going to go to vertex form. So we're going to set the equation equal to 0. So remember, to go from standard to vertex form, we have to complete the square, which means we're going to move the constant to the other side, leave a blank, like that. Then, since our a value is not a 1, we're going to factor this out of both of these. So factoring out the 2, 2 goes into 2 one time, 2 goes into negative 8, negative 4 times. Now we're going to go ahead and complete the square. So remember the little formula that we use to make a perfect square? We're going to take the b value divided by 2 and square it. So negative 4 divided by 2 squared is 4. So now we just made a perfect square. Then we have to multiply the 4 times the 2 to get the 8, which we add. If you add 8 on the left, we have to add 8 on the right. And that's going to make 1 over here. Okay, now changing forms. So a value comes down, x comes down. We take half of the b value, squared, and then we move the 1 to the other side. So we subtract it on the right, so we subtract it on the left. And since that turns back to 0, we can change that back to a y. And now we're in vertex form. Although now, if we were solving in vertex form, we'd have to set it equal to 0, add 1, divide by 2, one half. Aha! Take the square root to cancel out that square. Nice. Now we're going to put our plus and minus down. We got the square root of 1 over the square root of 2. And add the 2 on both sides. So now we have to simplify this. So let's do that over here. Square root of 1 over the square root of 2. Well, the square root of 1 is 1. Rationalizing the denominator, we get the square root of 2 on top, and the square root of 4, which is 2 on the bottom, plus 2. And that's good enough. So the two solutions are the square root of 2 over 2 plus 2 and negative square root of 2 over 2 plus 2. Thanks for staying tuned for that extra bonus problem. See you tomorrow.